All right, this is on multiple representations of a function. Here's an example. An amusement park manager estimates that the daily profits by multiplying the number of tickets sold by 20. This verbal description is useful, but other representations of this function can be more useful. So these are some different representations the manager can do to set up. So number one is we can write an equation. P equals 20 times N, where N represents the number of tickets sold. We can also create a table. So we have 50 tickets, profit is 1,000, or we can graph it out on a coordinate plane, where we have the horizontal axis represents the number of tickets sold, and the vertical axis represents the profit. Here are a chart for helping you to identify the multiple representations. You can create a table, you can graph it, write an equation, and describe a verbal description. Please go ahead and pause to see the rest of this table in its entirety. Example 2. Kurt is rappelling down a 500-foot cliff at a rate of 6 feet per second. We want to create a table, an equation, a graph to represent Kurt's height from the ground with relation to time. And then we want to answer this question: when will Kurt reach the ground? So first step is to create a table. So we want T representing the time in seconds, and H representing the height. So T will be the time in seconds, and H will be the height in feet. So to start off with, when it's 0 seconds, he's at 500 feet. And then what we're doing is we're subtracting by 6 after each second. So you'll see the values going down. And what we want to do is we want to make a prediction of when will he be at the ground. So we're going to try and find out this number right here. So next thing we want to do is we want to create an equation. So to write an equation, we're going to say that our height is equal to 500 minus 6 feet per second. So now let's write an equation. So H equals 500 minus 6 feet per second. So this is our equation. The next thing we want to do is we want to graph it. So we're going to find the intercepts and graph the line. So I'm going to change that equation so it's in slope-intercept form. So I'm just going to rewrite it as negative 6t plus 500. Now we want to find the intercepts. So notice I have this already graphed out, but the horizontal traditional x-axis represents the time, and then the vertical axis, the y-axis, represents the height. And to find the intercepts in y equals mx plus b form, the 500 is our y-intercept. So over 0, up 500. So there's that first y-intercept. And then we want to do our slope. So we can go down 6, right 1, or find out what this intercept is right here, which is our x-intercept. So to do that, we're going to let our height equals 0. So here's our height of 0, and we want to find that time. So we're going to say 0 equals negative 6t plus 500. We'll subtract 500 from both sides, and then divide both sides by negative 6. So our time is approximately 83.3 seconds. So this is our x-intercept, and this is our y-intercept. And then what we do is we connect the 2 points, creating that line. Now we want to go ahead and answer the question, when will he reach the ground? This is the ground when the height is 0. So Kurt will reach the ground after 83.3 seconds. All right, here's our second problem. Stacy runs 3 days a week at a track. Stacy starts keeping time when she starts warming up and notes every 2 laps how long she has been at the track. The table shows the times for several laps. Use a graph and equation to find the time it'll take Stacy to run 20 laps. So what we do is we create a table. So we're going to let X represent the number of laps. And we'll let Y be the time in minutes. So 2 laps, 13 minutes. 4 laps, 16 minutes. 6 laps, 19 minutes. So what we want to do first is we want to find the slope, so the change in y over the change in x. So I'm going to have this be my first ordered pair, x sub 1, y sub 1. And I'll have this be my second ordered pair, x sub 2, y sub 2. And we're going to find that slope. So we substitute the ordered pairs in, and we get 16 minus 13 divided by 4 minus 2. We're going to simplify the numerator, 3, and the denominator, 2. So we know the slope is 3/2. Then we're going to go ahead and substitute that into the point slope formula. So y minus y sub 1 equals m quantity x minus x sub 1. Now you can choose. You can choose the first ordered pair, which that's what I'm going to do, and then our slope. So we substitute the point and the slope in for x sub 1, y sub 1, and m. And now we're going to convert this to slope-intercept form. So to do that, we're going to distribute the 3/2 into both of those binomial, or into that binomial. So 3/2 times x is 3/2 x. 3/2 times negative 2 is negative 3. And then I'm going to add 13 to both sides. And then simplify. So negative 3 plus 13 is 10. So now I have my equation in slope-intercept form. This is my slope, and that's my y-intercept. Now I'm going to go ahead and graph the line. So my x-axis is the number of laps, my y-axis is going to be my time. And I'm going to start off with my y-intercept of 0, 10. And then I'm going to plot those points. And you'll see that trend is rising. Now it asks us to answer the question, how long, so that's our time, that's what we're trying to find, will it take Stacy to run 30 laps? So if you think about this, this is our numbers here going from 4, 8, 12, 16. When will she get to 20 laps? So somewhere up here we'll have our time. So what we can do is we can say X is our amount of laps, 20 laps, and we want to find Y. So we use our equation. Y equals 3/2 X plus 10. And we substitute 20 in for X. Then we simplify that. We can divide both of them by 2, the common factor, so that becomes a 10. 3 times 10 is 30. 30 plus 10 is 40. So how long will it take Stacy to run 20 laps? That'll be 40 minutes. It'll take Stacy 40 minutes to run 20 laps.